Today, once again, we are still looking for critical points of quadratic equations. But specifically today, we are going to be finding them from vertex form. Yesterday, we saw 3 different forms with our quadratic equations. And so we are going to be talking about those 3 forms individually over the next few days because there are some similarities in the way that we find these critical points, but there are also some key differences in the way that we find these critical points here. So just as a reminder, this is what vertex form looks like. We always have our f of x. We have a x minus h in parentheses squared plus k. Now, obviously, when we actually see problems, the a, h, and k, those are going to potentially be numbers. They could be 0, in which case they wouldn't show up. But we will have numbers plugged in for each of these. The critical points that we are going to be finding are the same that we saw yesterday. We're going to need to find the vertex, the axis of symmetry, and the y-intercept. We will also need to determine if the vertex is a minimum or a maximum. So we are still looking for the exact same things that we saw yesterday, but rather than graphing it out, we are going to be looking at the function itself. We're going to be looking at the equation itself in order to determine these things here. All right, so let's look at an example and let's start finding these parts individually here. So let's have f of x equals 2, and then we'll have x minus 5 squared, and then minus 4. So we're going to start by finding the vertex. So that was the first thing that we found yesterday, and I mentioned that that was the most important point that we are looking for on these problems. So the vertex is always going to come from this letter h and this letter k right here. Specifically, we are going to take the opposite of the number that's inside the parentheses, so that's negative h and positive k. So whatever number we have inside the parentheses here, that's going to give us the x value for our vertex, but that sign is going to be reversed. So in this case, we have a minus 5 inside the parentheses, which means our vertex will have a positive 5 for the x value. The sign there gets flipped. If we have a negative inside the parentheses, that becomes positive 5 for the vertex. If I had a positive number in here, it would become negative for the vertex. It's kind of like when we saw our transformations. We always said that the number inside was reversed or backwards for its horizontal translation. If we have a minus 5, we said that moved 5 spaces to the right. Well, that's the same thing as having a positive 5 here for our vertex. The y value that we get comes from the number that we have added or subtracted outside the parentheses on the end, similar to our vertical translations that we saw. However, just like the vertical translations, our sign here stays the same. This negative 4 would have moved our graph 4 spaces down, and so our vertex will also have the same sign. the sign for the x value is reversed from what was inside the parentheses. And the sign for the y value stays the same. So the next thing we want to look at is we want to determine our axis of symmetry. And who remembers how we find our axis of symmetry? What do we need to look at in order to find the equation for our axis of symmetry? Right, so we have the axis of symmetry being that line in the middle of our graph. And that line always went through the middle of the vertex. So we are using one of the two numbers from the vertex. Which number are we going to use from our vertex? We're going to use the 5. We always use the x value for our vertex here. So I'm going to erase this paragraph right here, or that sentence here. And the axis of symmetry. Yes, I did. Do you want me to go back? Okay. All right, so the axis of symmetry is always going to be x equals negative h, just like we had from the vertex here. So whatever number we have from the vertex is, whatever number we have for the x value from our vertex, that's going to be the same as our axis of symmetry. So x equals positive 5. Whatever number we have here is going to be the number that we have for our vertex right there. The other thing that we needed to find from our vertex was we needed to determine if the vertex was a minimum or a maximum. So we need to figure out whether our graph opens up or opens down. And if you remember, the graph opening up looks like this. And so then the vertex would be at the bottom. So if the graph opens up, the vertex is at the bottom, and we say that that's a minimum. If the graph opens down, then the vertex will be at the top, and we call that a maximum. So we need to determine whether our graph opens up or opens down in order to determine whether we have a minimum or a maximum here. So looking at our equation, there is one number up here which will determine whether our graph opens up or down. And that is the number that we have in front of our parentheses right here. This 2 here is positive. So if this 2 is positive, what do you think? Is this graph going to open up or open down? It's going to open up. If this number is positive, if the number in front of the parentheses is positive, the graph will open up. And we called that number A over here. So if A is positive, then the graph will open up and the vertex will be a minimum. If A is negative, then the graph will open down and the vertex will be a maximum. So in this case, In this case, 8 equals positive 2. So we can say the graph opens up and the vertex is a minimum. The last thing we need to look at is we need to look at how we find our y-intercept. So I'm going to erase this here because I'm just out of space. All right, so y-intercept this is the one that actually requires a little bit of calculation, but it's an easy calculation because the way you calculate it is the same for all of the problems. For the y-intercept, you're going to plug 0 in for x, and you're going to work out what the result is. The y-intercept you're going to write as 0, comma, whatever your y is there. So you plugged in 0, that's where the first number in the point comes from. The second number is the number that you're going to calculate. So if we're calculating our y-intercept, most everything is going to stay the same, but I'm going to plug 0 in for x, which means I'm calculating f of 0. So I'm going to plug 0 in for this x right here. I'm going to plug 0 in for this x right here. Remember, we've seen this before. We are not going to do anything to the left-hand side. This f of 0 is going to stay the same. It's the right-hand side that we are actually working out. So we need to make sure that we are following our order of operations. You want to make sure that you start with your work inside the parentheses. So 0 minus 5 will give us -5. We're still going to have the power of 2. We are still going to have the 2 out front. We'll still have the -4. And like I said, f of 0 on the left-hand side will stay the same the whole time. But what's going to come next here? This is the one place where people make common mistakes. Am I going to multiply by 2 next, or am I going to take the power of 2 next? Why are we doing the power of 2? Okay, so your reasoning is a little bit off, but your answer is correct. We are going to do our power of 2. When we say parentheses, we mean work inside parentheses. So this first step right here, 0 minus 5, that was our work inside parentheses. When we have this power of 2, that counts as an exponent. And that's the thing that comes after parentheses in our order of operations. And that comes before the multiplication that would be out in front of the parentheses there. So this 2 in front of the parentheses stays the same. I'm going to keep these parentheses for the moment. But -5 to the power of 2, -5 times -5 will be +25, and that is important here. One important thing to note, One important thing to note, if you were to put this in your calculator without the parentheses, if you were to put it -5 to the power of 2 without parentheses, it would in fact give you a -25 as a result. So make sure when you are working these out, if you're using a calculator, you use the parentheses just like I've written them here. There's a reason that I'm writing them out, and that's because that's how you need to write it in your calculator. So we know that a negative times a negative should give us this +25 right here. We still have the -4. And then we can keep going with things. So 2 times by 25 will give us 50. We still have the -4 here. And then 50 minus 4 will give us 46. So our y-intercept comes from the two numbers we just were working with, the 0 that we plugged in, and this first number will always be 0. The y-intercept will always have a 0 for the x value. And then the number that we get as the result, in this case, was 46. So the y value here is 46. So if we put everything back together, without all the extra text here, we said that the vertex was the point +5, -4. We said that the axis of symmetry was x equals +5. We said that the graph opened up because of the +2. So the vertex is a minimum. And we also said the y-intercept is the point 0, 46. So those are all of the things that we were asked to find. The vertex, axis of symmetry, and the y-intercept. Vertex, axis of symmetry, maximum or minimum, and the y-intercept. So it's all 4 things that we needed right there. Those are the same 4 things that we were looking at yesterday, the same 4 things that we were trying to find when we saw these problems previously. Every type of problem in this unit is basically going to be asking for these same 4 things, but the way these problems start, the different forms that we're looking at, that's going to be where things get different on these problems. So for our next example, once again, we still have the same directions. The vertex, axis of symmetry, and y-intercept. Determine if the vertex is a minimum or maximum. And this time, let's have so we've got a problem here that looks a little bit different than the last one. We've got fewer numbers involved here. And so these are ones where we actually need to be careful because it's harder to necessarily tell what's going on with this. When we have numbers in every single place, these problems are very straightforward because we can see where everything is supposed to go. This problem, obviously, I have fewer numbers, and that's why we need to be careful, is because sometimes when there's fewer numbers, people get mixed up on which numbers represent which things. So just a reminder, our vertex form is this right here. That is a wonky looking A. Oof. 3rd time's a charm. So for this problem, because I'm missing some numbers, I want to explicitly identify what A, H, and K are. because I'm missing some things and because I don't see numbers in every place, I want to say what A, H, and K are before I get started with things. So in this case, we know that A is the number that's in front of the parentheses. Well, I just see a negative sign in front of the parentheses. So what number would that count as if we just have a negative sign there? If there's no number shown, that number should count as 1. So in this case, A is equal to -1. Because there's a negative sign with no number, A is going to be -1 here. Now H is subtracted inside. If there's no number subtracted inside, what number can we add or subtract that doesn't change anything? 0. So in this case, H is going to be equal to 0. And then K very clearly is going to be 8. Questions on how we identified those there? All right, so we want to start by finding our vertex. And we said previously that our vertex is -h, k. So if I know my values for h and for k here, what would be my vertex for this problem? If we plug in 0 for h and we plug in 8 for k, that's going to give me 0, 8 as my vertex. So if we know what our vertex is, what's going to be our axis of symmetry now? Specifically, though, how do we write it out? There we go, x equals 0. Thank you. We have to have that x equals. If it doesn't have the x equals, it's not entirely correct. As I mentioned yesterday, x equals represents a vertical line. If we don't have the x equals, then it's not a vertical line. It's just a number. Or if you have y equals, it's a horizontal line. So you specifically have to have x equals 0 in order for the axis of symmetry here to be correct. But there's no calculations involved. Once again, it's just whatever the x value is. Now, the next thing we want to determine is whether our vertex is a minimum or a maximum. So we need to figure out whether our graph opens up or down. So for this problem, what do you think? Does our graph open up or does our graph open down? If the A is positive, then the graph opens up. But in this case, A is negative. So it would open down. So let's draw a quick diagram over here on the side. If our graph opens down like this, then the vertex is going to be up here at the top. And so the vertex is going to be a maximum if it's up at the top right here. So we just want to explain what we were just thinking out loud. Since A is negative, the graph opens down and the vertex is a maximum. So once again, not really any calculations here. You just have to know which number to look at and what that number represents. So since this A was negative, the graph opened down and the vertex was up here at the top, which meant we called it a maximum. So for our y-intercept, this is where we actually have to do a little bit of calculations. So we're going to plug 0 in for our x's. Plug in 0 here and plug in 0 here. So if we work this out with order of operations, the first thing we need to do is 0 squared. What is 0 squared? It would be 0. Everything else stays the same for the moment. We talked about this earlier, but if I've got negative 0, what is that? 0. And then what about 0 plus 8? 8. So that means f of 0 is equal to 8. So then our y-intercept is going to be the point 0, because that's what we plugged in, comma 8. Once again, the instructions are going to be the same. And here, let's do the function f of x equals 1/2 parentheses x plus 4 squared. And that's it. So just like before, just like the last example, we see that there's some number that's missing. So I would suggest looking at your regular form and writing out your A, H, and K before you start trying to find everything you need. So once you identify your A, H, and K, then you can go ahead and you can start finding your vertex, your axis of symmetry. You can find all of that stuff. But start by finding out what A, H, and K are. That's going to help you out in the long run. All right, so if we identify our A, H, and K, A in this case is going to be 1/2. H is going to be 4. And what will K be here? If there's no number added or subtracted on the end of our problem, what is K in this case? 0. So here, if we know that H is positive 4, if we've got this plus 4 right here, that means our vertex is going to be -4, comma 0, because our k is 0, our y value is 0, and the x value is always reversed of whatever we have inside the parentheses here. That will be the #1 mistake that people make. People forget to flip that sign. The vertex, the x value of the vertex is always reversed of whatever you have inside the parentheses right here. So our vertex here is going to be -4, comma 0. And if the vertex is -4, comma 0, that means that the axis of symmetry will be x equals -4. Because the x value of the vertex is the same as the x value for the axis of symmetry. Next up, we have to determine whether our vertex is a minimum or a maximum. Well, A is 1/2 right here, so does our graph open up or does our graph open down? Is A positive or is A negative? It's positive, so our graph opens up. So therefore, the vertex is a minimum. So we've got 3 things we've found. The last thing we need to find is the y-intercept here. Once again, we're going to plug 0 in for our function. Zero plus 4 is going to give us 4 inside of our parentheses. Four squared, 4 times by 4 should give us 16. And then 16 times by 1/2 is the same thing as 16 divided by 2. And that should give us 8. So that means our y-intercept is going to be the point 0, comma 8.